Okay, so we'll be revising test 2. This is the medical mathematics 1 for those who are doing first semester at Unilus. Okay, so this test, I was passing through the questions, then I've realized that most of these test 2 questions were just repeated test 1 questions. Okay, so they repeated most of the test 1 questions in this test 2. Okay, so meaning that you guys are expected to pass test 2 like no man's business, because all these questions that I've seen there, I've seen them again in test 1, and we had revised test 1. Okay, so let's go to the questions. So there are 20 multiple choice questions. We're going to answer all of them. Okay, so this is question 1 here. So question 1, they're saying a specialist clinic measured systolic blood pressure in millimeters of mercury in a sample of 80 patients. Okay, and the readings were represented in the box and whisker plot given below. So we know that in the box and whisker plot, we're expected to find the maximum at the end of this box and whisker. So this is the maximum here. Then the minimum is there. Okay, and then here at the beginning of the box, we have your Q1, and then this one here, okay, the line within this box is our Q2, and then at the end of the box, this is Q3. And then if you have a dot like this one outside this box and whisker plot, we call this dot as an outlier. Okay, so this guy here, the one dotted in blue, is simply an outlier. Okay, so this is our box and whisker plot. So the question is, describe the distribution and the variability of the data that is being represented by this box and whisker plot. Okay, so we are going to start with the distribution. Okay, is the distribution skewed to the left or is the distribution skewed to the right? So how do we know that? Okay, we just compare the lengths of the whiskers. So these lines here that are coming from the box and then are going to this line that's coming from the box and then it's going to this line, those are what we call as the whiskers. Okay, so depending on the length of the whisker, we can tell that, okay, this distribution, the data is skewed to the left or skewed to the right. So you just compare the length, okay? So the whisker that is going to be longer is going to show us that the distribution is skewed to that side. So we see that on the left here, the distance or the length of this whisker is just very short. It's just this distance here. And then when we compare it to this whisker on the right, this whisker is very long. So the right whisker is longer than the left whisker. So it means our distribution should be skewed to the right. So this option C and option A, we can cancel it. So we are only remaining with B and D. Okay, so now the other part says with greater variability on smaller readings. The other one says with greater variability on the larger readings. Okay, so which one is correct there when we talk about the variability? Okay, so when we look at the whiskers there, okay, the longer whisker is on the right, right? So where you have the longer whisker, okay, we can also see that the spread on the right is the spread on the right is actually bigger because from this value here, which is between 130 and 135, okay, somewhere there, to get to this value here, the maximum, the distance here is quite big. So the variability, okay, on the larger values, because on this side of this whisker plot, we have the larger values. And then on this side here, we have the smaller values. So the variability on the smaller values is not that much because I'm just from 120 here, and then I can see another value here. So the variability here is not that much. Or even if I get this guy here and I compare it to this, the variability there is not that much. But if I get this value compared to this, you see that the distance here is quite long. So the variability is larger on the what? On the larger values. So we're going to pick D here as the correct answer, this one here. Okay, the distribution is skewed to the right, and then we also have greater variability on the larger values. So we pick D as the correct option there. Okay, so unless there are any questions, we'll move to question 2. Okay, so there are no questions. I'll move. So question 2, they're saying a hospital recorded the time in hours that it takes for its laboratory to issue test results. The sample on 11 patient samples yielded the stem and leaf plot below. So this is the stem and leaf plot that we've been given. Okay, so simply meaning that we have 12 minutes, 18 minutes, 20 minutes, 22, 24, 25, 28, 30, 32, 35, and then 40. So uh, we're going to use this plot, okay, the stem and leaf plot. We're going to use it to calculate the quartiles and then the interquartile range. And also, using the interquartile range, okay, we can identify if this data has outliers or it has no outliers. Okay, so let's start by calculating the median, which is just the Q2. And then after that, we can calculate Q1, and then we calculate Q3, and then we can calculate interquartile range. Okay, so how do we calculate the Q2, which is just the median? Okay, we just use the canceling method here to make it very easy. So if I cancel the last number, I should cancel the first number. Okay, the second last, I should cancel the second number. The third last, I should cancel out the third number there. And then the fourth last, I should cancel out the fourth number. Okay, and then if I cancel this one, I cancel out this one. So I only remain with 5. And this 5 is in the row for the 2. So it means there, my Q2 is actually 25. Okay, this one here. So this Q2 is going to divide the data into 2 equal halves. There will be the upper half and the lower half. So the upper half will be, okay, so this data has been divided into 2 equal parts by this median here. So the lower half, it is this part here, starting from 2 all the way up to 4. The upper half is starting from 8 all the way up to what? Up to 0. So the median of the lower half is what we call as the Q1. So I'll just start canceling again. So cancel 4, cancel 2, cancel 8, cancel 0. So I only remain with 2. So this is my Q1, the median of the lower half of the data. So this is 22. So Q1 is 22. And then Q3 is just the median of the upper half of the data. So I can cancel 8, I cancel 0, I cancel 0, I cancel 5. So I'm remaining with 2 again. So this is 32. So it means the Q3 is just what? 32. Okay, and then what is the interquartile range? So interquartile range is the difference between the Q3 minus the Q1, which will just be 32 minus 22. Okay, this will give me what now? Okay, this will give me what? This is going to give me a 20. Okay, so the interquartile, is it 10 or 20? Okay, so interquartile range is what now? Okay, so the interquartile range is okay, so let me look at this again. So the Q1, I found it was what? 22. Okay, so the Q1 there, I think I made a mistake. I should have found 20, right? So because I'm canceling like this, look at this. So we said the 5 or the 25 has divided the data into 2 parts. So if I cancel this 4, I should cancel the 2. If I cancel out this 2 here, I mean this 8 here, I should cancel out the 2 here and note this is 0. Okay, so the Q1 should be 20 there and not 22. So I made a mistake there. Okay, so let's put 20 there. So this is 20. Okay, so that's it. Here it's just going to be 20 like this. And then for the Q3, I didn't make a mistake. I just found it correctly. So 32 minus 20, I'm going to find my interquartile range to be 12. Okay, so interquartile range is just 12. And then we're now just remaining with it, determining if this data has outliers. So the range, okay, of accepted values, is given by, okay, Q1 minus 1.5 multiplied by the interquartile range. Okay, so someone has raised their hand. You can ask the question. Lushomo, you raised the hand. You can ask your question. Okay, maybe it was by mistake. So I was saying the range of accepted
No,
values. Oh, okay. You can
I have
ask.
a question.
Yes, you can ask.
Paul, we asked if you can explain question 2 again.
Okay, question 2 again. Okay. So I'll explain
And
it.
actually,
Okay. So
okay,
here
thank
on
you.
question 2, we've been given the stem and leaf plot for this sample data on 11 patients that takes that records the time in hours that the laboratory takes to issue out test results. Okay, so this guy here, this part here is the stem, and then these are the leaves. So the stem, it means the first part of the number. Okay, so if I have a stem as 1 and then leaf 2 and 8, it simply means here I have the time in hours. Okay, the first one will be 1 and this 2, so it will be 12 hours. So it means the first patient that they took the time, okay, was 12 hours. And then the second patient will just be 18 hours, like that. And then if I go to the stem for 2, this will be 20, okay? I can add 20 there, then 22 hours, and then 24 hours, and then 25 hours and 28. So this is the data. It's just been represented by the stem and leaf plot. And then from this stem and leaf plot, okay, we are supposed to find the quartiles. And then using the quartiles, we find the interquartile range. And then using the interquartile range, we find the range of accepted values. Okay, and then from there, we can tell if we have outliers or not. So how do we find these quartiles? Okay, the quartiles is just the Q1, the Q2, and the Q3. So of these three quartiles, the Q1, Q2, and the Q3, the most common one is the Q2, which is also known as the median. So the median is just the middle value of the data that you have. Okay, so the value that you have on the middle, okay, in your data, that's what we call as the Q2. So for example, if I arrange the following data, okay, if I just say I have 10, 11, 12, 13, 14, which one is my median here? My median will be this one, 12, because it's on the middle, okay? On the left side, I have 2 data points. On the right side, I have also 2 data points. So the 12 is on the middle. So the way this stem and leaf is arranged, it is arranged in order, meaning from the lowest number to the highest. So the lowest number here is just this 1 and 2, which is 12. The highest is this 4 and 0, which is what? 40. So for me to find the Q2, okay, I can just use the cancelling method. Okay, so same same as here. Okay, if this is the simple example that I have. If I cancel out the first data point, I should cancel out the last one. If I cancel out the second data point, I should cancel out the second last. Okay, until I just remain with one in between. So that's the method that I used. So I canceled out this 0, which was the last one, and then I cancel out the first one. If I cancel out the second data point, I should cancel out the second last. The second last is this 5. Okay, the third one, the third last, I cancel it again. Okay, the fourth one, the fourth last, I cancel it. Okay, the fifth one, the fifth last, I cancel it. So I only remain with the 5. So it means this 5 here is the one that is on the middle, right? Okay, but this is just a leaf. In which stem is it? It is in the stem for the 2's. So it means my median will just be 25 like this. So it's the one that I wrote here. So now the median, okay, will divide the data into 2 equal parts. Okay, there will be the upper half and the lower half. So the lower half will be from 2 all the way up to this 4 before I reach this 5. And then the upper half will be from this 8 all the way up to this 0. Okay. And then using the upper half, okay, and the lower half, you can actually calculate the Q1 and the Q3. So the Q1 is just the median of the upper half. So the upper half is from 2, I mean the lower half. The lower half is from 2 to 4. So if I cancel out the first one, I cancel out the last one. The second last, I cancel out if I cancel out the second one, I mean, I need to cancel out the second last like that. So I only remain with 0. So this is in which stem? It is in the stem for 2. So this is 20. So no wonder I said Q1 here was 20. And then we do the same for the Q3. Okay, we cancel out the first one, which will be 8 there. Cancel out the last one. cancel out this 0, cancel out this 5. So I only remain with these 2. And it's in the stem for the 3. So meaning this is 32 here. Okay, no wonder the Q3 was 32. Okay, so the one who asked how we are finding this, I hope you've gotten it now. And then now to find the interquartile range, we just said interquartile range was equals to the Q3 minus the Q1. So the Q3 is 32 minus the Q1, which is 20. So this gave me a 12. This is the 12 that I've written down here. Okay, so the one who asked, is it clear there? Okay, I'll assume it's clear. So I can now erase this and find out if this data has an outlier or it does not have an outlier. So the range of accepted values is given by the formula Q1 minus 1.5 multiplied by interquartile range, okay, comma, Q3 plus 1.5 multiplied by interquartile range. Okay, so meaning the range of accepted values will be Q1 is 20, okay, minus the interquartile range is 12. I need to put a 1.5 in front. So 1.5 multiplied by 12, comma, and then the Q3 is 32 plus 1.5, and then interquartile range is 12. Okay, so when I do this on my calculator, 20 minus 1.5 multiplied by what now? Multiplied by um okay, multiplied by 12. What do I get? Okay, so 20 minus 1.5 multiplied by 12, I get 2. So 2, comma. And then on the other side, I have 32 plus 1.5 multiplied by 12. So I get 50. So this is the range of accepted values. So we see that from our stem, all these values that I have here, they're just within this range because the lowest here is 12. 12 is between 2 and 50. The highest is 40. 40 is between 2 and 50. So since all the data points here are within the range of accepted values, we're going to say that our data has what? No outliers. Okay, so now we just pick the option that has whatever we've discussed here. So the Q1 should be 20. So I have 2 here. The Q2 should be 25, I have 2. The Q3 should be 32, I have 2. The interquartile range should be 12, I have 2. And then the only difference will be on the outliers. So here, since all these values here are in the accepted range here, we're going to say no outliers. So we're going to pick this guy here as the best answer. Going to pick that guy as the best answer. Okay, so any questions there before we go to question 3? Okay, so let's go to question 3. So question 3 here, they're saying a study was conducted to measure the cholesterol levels in milligrams per deciliter. Okay, so of 15 individuals after a dietary intervention. The recorded values are as follows. So these are the recorded values, okay, for 15 individuals. Okay, so the question here is enter the data into your calculator. What is the sample mean and the variance? So this was the easiest question because you're just using the calculator. Okay, so now there are different calculators. Okay, so I think I'll create a separate video here where I'll be showing you how to enter these values on the calculator and then you come up with the mean and the variance. Okay, in an easy way. So there's a Casio calculator, there's Sharp. Okay, there's also Kenko for those who use Kenko. So I'll create a video showing you how to use each one of these to just get these values, the mean and the variance direct from the calculator. Okay, but if you want to calculate these things directly, okay, without using a calculator, you can use the following formulas. So the mean, okay, the mean is equals to the summation of all the x that you have here and then divided by how many they are. So you add all these, this plus this plus this plus this, all the way to this. The total that you're going to get, you're going to divide it by 15. You're going to get your mean, okay? And then the variance, you're going to use the formula for the sample variance, which is equals to, the variance, okay, is equals to 1 over n, okay, minus 1. And then in the brackets, I'm going to have the summation of the x squared, okay, minus the summation of x, I square it, and then I divide by n. So you can easily do this, okay? But if you want, you can just use the calculator. I'm going to create a separate video where I'm showing you how to use the Casio, Sharp, or even the what? The Kenko. But the answer that you should get here is that the mean is 191.20, and then the variance is 45.74. Okay, so I'll create a video here on showing you how to use the calculator in case you don't know, but you should know, okay? Because in the exam, such a question is going to come. Okay, so you can just easily find the answer from the calculator. Okay, so I'll move to question 4, where we can solve something. So question 4 is a question on probability. Okay, so here they're saying, at a certain specialist cancer hospital, the possibility of having a cancer operation done depends on the availability of a specific specialist oncologist. Okay, from past records, the hospital notes that the probability of having this specialist at the facility is 0.51. If, okay, this specialist is around, the probability that the hospital authorizes a cancer operation is 0.83. If this specialty is not around, this likelihood or the probability of authorizing a cancer operation reduces to 0.44. Now the question is, find the probability that the hospital authorizes a cancer operation and this specialist is not around. Okay, so I'm going to say, let S, okay, represent the event, okay, that the specialist is around. Okay. Okay, let S be the event that the specialist is around. Specialist is around. Okay, and then um, let A be the event that they authorize an operation. Okay, they authorize a cancer operation. Okay, so I'm going to say the probability of S, meaning the specialist is around, is 0.51. We've been given here. And then if around, okay, if around, the probability that they authorize a cancer operation is 0.83 there. So a probability of authorizing, meaning this event A, is just equals to 0.83. And then here they also said, um, if this specialty is not around, this likelihood drops to this. So this simply means the probability, okay, of authorizing the operation given that this guy is not around. So if this guy is not around, then we are talking about the S complement event. Okay, because the S means it's around. So S complement will mean that it's not around. So the probability of authorizing the operation given that this guy is around, okay? Given that this guy is not around, okay, is equals to 0.44. So now here we want to find the probability that the hospital authorizes a cancer operation and this um and this guy here is not around. Okay, that's what we want to find. So there we're just finding the intersection of some events. Okay, so we're finding the probability that the hospital authorizes, okay, and so this and is the key word, simply means intersection. Okay, the probability that the hospital authorizes and meaning of intersection, the specialist is not around. So meaning that AC complement like this. So this is what we are looking for. So how do we find such a probability? Okay, so remember from the given um, from the conditional probability. Okay, if I have probability of A given B, this is the same as probability of A intersection B over what? Probability of B. So this is the formula that I'm going to use. So I'm going to say probability of A, given that the specialist is not around, okay, is equals to the probability of A intersection S complement divided by the probability that S divided by the probability of S complement, I mean. So I'm just following this formula. So what we want to find is this guy, which you can see on top there. Okay, so I can say cross multiply. So the probability of A intersection S complement here is going to be equals to this guy multiplied by this. So probability of S complement multiplied by the probability A given that S complement. Okay, so we just have to find this and this, but this here has already been given as that. So we just have to find the probability of S complement. So we have the probability of S. So we can easily find the probability of S complement by the complement rule. So we're going to say probability of S complement is just going to be equals to 1 minus the probability of S. So this is 1 minus 0.51. So what does that give me? It gives me 0.49. Okay, so that's what I'll put here. So I'll say probability of A intersection S complement, I mean, is equals to, this probability is 0.49 multiplied by the probability that they authorize, given that this guy is not around. So 0.44 like this. So we multiply this. What are we going to get? So punch this on the calculator. So 0.49 multiplied by 0.44. This gives me 0.2156. Okay, so I can round this off to two decimal places. I get 0.22 like this. So you can see that's the option on A. So we pick option A as our best answer. Okay, so any questions there? Okay, so if there are no questions, I'll move to question 5. Question 5 is the same question, but now here they're saying find the probability that an intern will, is it the same question? No, it's not the same question. Okay, so let's read the question. So here they're saying a hospital, okay, gives awards to its intern medical staff based on their levels of courtesy and punctuality. The probability that an intern gets a courtesy award is this one here. So courtesy, let it be the event C. So the probability of C, okay, is equals to 0.32. And then the probability that they get a punctuality award, so probability of punctuality P is equals to 0.21. And the probability that they get both, so meaning probability of C intersection P is just equals to 0.15. So now the question is find the probability that an intern will get no punctuality award given that they have gotten a courtesy award. So it's here, we're going to use the complement rule. We are first going to find the probability that this intern gets the punctuality award given that they have gotten the courtesy award. And then from that, we're going to, then we're just going to subtract that probability from 1 to get the probability that the intern will not get, okay, the punctuality award. So probability that this intern gets the punctuality award, given that, okay, they have already gotten the courtesy award, is given by this. So this will just be the probability of P intersection C, which is the same as C intersection P over probability of C. Okay, so this guy, we have it there is 0.15 over probability of C, 0.32. So if I divide this, what do I get? I get 0.46875. So this is the probability that the intern will get the punctuality award, given that they have already gotten the courtesy award. And then now to find the probability that this intern has not gotten the punctuality award, meaning P complement, given that they've gotten the courtesy award, it's just going to be 1 minus the probability that they get the punctuality award given that they already have the courtesy award. So this will be 1 minus, this probability is what I calculated there. So it will be 0.46875. So 1 minus this, it's going to give me what? It's going to give me 0.53125. So round it off to 2 decimal places, it's going to give me 0.53. So that's the answer that we can see on A there. So we pick A. Okay, so any questions there? Okay, so we go to question 6, which is the similar questions now. Okay, so I was ahead of myself. So probability of C has been 0.32. Probability of P is 0.21. Probability of C intersection P is just 0.32. So here, what are we finding? Okay, so they're saying find the probability that an intern will get only one of the two awards. So this is the probability that, okay, this intern will either get the punctuality awards and that's all, or this intern will get the courtesy awards and that's all. So the probability, okay, that they only get one, okay, of the two awards is equals to the probability of only getting, okay, the punctuality awards plus the probability of only getting the courtesy awards. Okay, only getting the courtesy award. So how do I find this probability of only getting the P award? Okay, this probability is simply going to be the probability of P, and then I subtract what is in the intersection. So the intersection, the probability of C intersection P like this. So this one here will represent the probability of only getting the punctuality awards only, okay? And then plus, even this guy here do the same thing. It will be the probability, okay, of getting the C awards, and then I subtract what is in the intersection. So the intersection there is going to be what now? What would be the intersection? Okay, so the intersection is going to be P, C intersection P. Okay, so we see that these things are the same. So it will be probability of P plus probability of C minus 2 probability of C intersection P. So probability of P is 0.21 plus probability of C is 0.32 minus 2, the probability of their intersection, which is 0.32. So this is going to give me what? So I just punch that on the calculator. Okay, so I'm getting 0.23. So you check on your answers if you have 0.23. Okay, so I can see it on B. So we're going to pick B there as the what? As the best answer. Okay, so any questions there? Okay, so if there are no questions, I'll move on to question 7, which is still the same question, but here they are asking us what? So the probability of P is what? 0.21. The probability of C, 0.32. Then the probability of C intersection P is equals to 0.15. So here they're saying find the probability that an intern will get at least one of the two awards. Okay, so at least one of the two awards means that they can get just one award or they can get both of the awards. So that is the probability of P union C. Okay, which will just be the probability of P plus the probability of C minus the probability of C intersection P. So this will be 0.21 plus 0.32 minus 0.15. So get your calculators, you punch this value, what are you going to get? My calculator is saying 0.38. So 0.38, and then I check if on my options I do have this answer. Okay. Oh, I have it here. So I'm going to pick D as my best answer there. Okay, so any questions there, guys? Okay, let's look at question number 8. Okay, so question number 8, they're saying a medical researcher is studying how a sedative is absorbed into the bloodstream from the stomach. Okay, so the rate at which the drug enters the bloodstream is modeled by this equation here. So this equation describes the rate at which the drug enters the bloodstream, where A prime of T is in milligrams per hour, and T is the time in hours after the administration of the drug. Okay, if the initial amount of the drug in the bloodstream was 12 milligrams, how much, okay, is present after 4 hours? So this one here, the equation here is for the rate. So for us to find how much is present after 4 hours, we need to find the equation, okay, that describes the amount. This equation here describes the rate. So how do you find that equation, which will be indicated by AT? Okay, this equation is found by integrating this guy. So it will be the integral of 6t plus 3t squared, okay, and then dt. So if I integrate this, it will be 6t squared over 2 plus 3t to the power 3 over 3, and then I put a constant of integration there, which is c. Okay, so in case the meeting cuts, just rejoin using the same link. Okay, so this one is just 3t squared, 3t squared plus, this is just t to the power 3 plus c. Okay, so this is my AT. But now I need to find the value of the c. Okay, so here I've been given the initial a value. They're saying if the initial amount of the drug, okay, in the bloodstream was 12, so meaning at time 0, okay, the amount of the drug was 12, okay. I can use that information to find this value of what? C. So at time 0, meaning A0, okay, this is just going to be equals to 12. So wherever there's T, I'll put 0 there. So this guy, okay, will be 12 at time 0. And then wherever there's T, I put 0. So if I put 0 here, it will just be 3 multiplied by 0 plus 0. So C. So C is just going to be equals to what? To 12. Okay, so it was like this. So let me erase this part here. Okay, so the C, we found it was 12. So it means the amount of drag at the time t is going to be equals to this equation. Then I put the value of t, of c there. So this here was just 3t squared plus, this one here was just t to the power 3 plus, the c is this 12 here. So I'm just going to put plus 12. Okay, so that is the equation that we're going to use to find how much is present after 4 hours. So meaning the time is 4. So amount at 4 is just going to be 4 squared plus 4 to the power 3 plus 12. So we can punch that straight onto the calculator. So it will be 3 multiplied by 4 squared plus 4 to the power 3 plus 12. So that is going to give me 124, okay, milligrams. So I'm going to go on the options and then I'm going to select 124. Okay, so any questions there? Okay, if there are no questions, let's go to question 9. So question 9, okay. Question 9, they're saying an IV bag contained 1,170 milliliters of a solution, and its infusion into the patient's bloodstream started at 7 hours a.m. and it ran until 13:35 p.m. Okay, with the rate flow equaling 5 drops a minute. So at 13:35 p.m., the IV bag, okay, contained 620 milliliters of this solution. Find the drop factor. Okay, so to find the drop factor, we need one, the total number of drops, and then we need the volume that has been infused. Okay, so here I'll start with the time. Okay, so the infusion started at 7 a.m. It ended at 13:35. So what is the time in hours that elapsed from this time to this time? So just I'm going to subtract these 2 times. Okay, if I subtract those 2 times, I find 6 hours 35 minutes. That's the time. So I'm going to convert this time to minutes. Okay, so the 35 minutes are already minutes. I'm just going to convert these 6 hours to minutes. So how do I do that? I multiply the 6 by 60. It's going to give me 360 minutes. So 6 hours is the same as 360 minutes. And then I add plus 35 minutes. So it's going to give me the time of 395 minutes. So that's the total time. Okay, and then the total drops. The total drops will be equals to, okay, the drops per minute times the total time that you have. So drops per minute is 5, okay, multiplied by how many minutes do I have? I have 395 minutes. So if I multiply this question was there even in test 1. Okay, if I multiply 5 multiplied by this, I'll get 1,975 drops. Okay, so this is the number of total drops, and then from there, I just have to find the volume infused. So volume infused, okay, will be equals to the volume that we had at the start and minus the volume that we had at the end. So at the start we had this, so 1170 minus at the end here we had 620 like this. Okay, so we're going to subtract those two. So it will be 1170 minus 620. So this is just going to give me 550 milliliters. Okay, so the drop factor now, we can calculate it. So we're going to say drop factor, DF, is just going to equals to the total number of drops, 1975, okay, divided by the volume infused, which is 550. So this is just going to give me what? So you can divide that on the calculator. So 1975 divided by 550. So it gives me 3.5909090 until forever. So I can round it off to one whole number or to the nearest whole number. So it just gives me 4 drops per minute, per milliliter, I mean. Okay, so you go on the options, you look for 4 drops per milliliter, which I can see on what? A. So I'm going to choose A as my best answer. Okay, we go to question 10. Question 10 is on the recurrent relation or the recurrent sequences. So here they're saying the concentration measured in milligrams per liter of a drug in a patient's bloodstream is modeled by this recurrent relation here. Okay, where Cn, this one here, represents the concentration after the nth dose, and C0 is equals to 0. Calculate the concentration of the drug in the bloodstream after the 3rd dose. So for us to find the concentration after the 3rd dose, then we have to find the concentration after the 1st dose, concentration after the 2nd dose, because this is a recurrence relation. Okay, so I'll start first by finding the concentration after the 1st dose. So it will be C1 is equals to 0.5. So here my N is equals to 1. So if my N is 1, here I have N minus 1. So that will just be C0 and then plus 2. Okay, but C0 here we've been told it's what? It's 0. So this is 0.5 multiplied by 0 and then plus 2, which will just be 2. So the concentration after the 1st dose is just 2. So C1 is equals to 2. Okay, so C0 is 0. C1 I found it is 2. Okay, so that's just the concentration of the 1st dose. And then if N is 2, that will be the 2nd dose. So C2 will be equals to 0.5 and then C1 plus 2. Okay, so this will just be 0.5 multiplied by C1, which is 2 plus 2. So this is going to give me what? Okay, so that will be 0.5 multiplied by 2, that will be 1, and then 1 plus 2, that will be 3. So the concentration after the 2nd dose will just be what? 3. So C2 is 3. And then we can find after the 3rd dose now. So C3 is equals to 0.5 and then C2 plus 2. So this will be 0.5. C2 is 3 and then plus 2. So we multiply this on the calculator. 0.5 multiplied by 3 and then plus 2. So that will be 3.5. So this is 3.5, and we know that the concentration is measured in milligrams per liter. So after the 3rd dose, okay, the concentration will be 3.5. So you look at your options. Is there a 3.5? Yes, I can see it. It's there. So you pick it as your best answer. Okay. So any questions there? Okay, so thank you so much for watching this video. If you'd like to access the full video solutions for this test 1 revision, you are welcome to register with us. Okay, on our website, we have a full video for this test 2. Okay, and also test 1, quiz 1, as well as we're going to solve the mid-semester exam. So you can watch all those videos to prepare for your exam at your own pace, at your own time. Okay, so to access the full video for this test, so in this video, we've only solved question 1 up to question 10. So for question 11 up to question 20 there, okay, you are welcome to register with that. You're going to find the full video on our website. So on our website, you're also going to find full videos for all the tutorial sheets. So you have what? 7 tutorial sheets. Okay. You're going to find full videos for all the tutorial sheets. So for example, this was tutorial sheet what? This here was tutorial sheet 7 on probability. We've solved all the questions here. Okay, and you can access the video on our website. This was tutorial sheet 6. Again, we've solved all the questions here, and you can access the video on our what? On our website. Okay, so when you go on our website, you're going to see something like this. So you can register for your for the course of your choice. Okay, so if it's math, you register for math, and then there I should write enrolled after you make a payment. So once you open this math course, okay, you can go to the folder for general mathematics. Okay, so if you want the videos for the test 2, for the test 1, you go in this folder for past quiz test and exam papers. You open it. Okay, and then you go to the Unilus folder, because that is a test paper for Unilus. Okay, and then you go to, it depends. If you're in first semester, you go here. If you're in second semester, you go here. Still going to find videos. So if you're in first semester, you can go in first semester. Okay, and then you go to the video solutions. So the video solutions here, you see that you find the quiz 1 there, we solved it. The test 1, even for the January intake, the test 2 for the January intake, the test 1 for the 2025 July intake, and this is the test 2 full video, okay, of those questions that have been solving. So we've already solved it, and you can access it here and learn at your own time and at your own pace. So if you want, again, you can go to the folder for the tutorial sheet and assignment here. So you can open this tutorial sheets and assignment folder, and then you go to Unilus. Okay, if you want the tutorial sheet for semester 1, you go here. If for semester 2, you go here. We've solved all of them. So you can go to semester 1 here. Okay, and then you go to the video solutions. You're going to find all the videos here. So 2025 July intake, if you want, you can watch for the 2025 January intake. You can see here from tutorial sheet 1 all the way up to sheet 7. We've already solved them, and they are here ready for you to watch anytime, anywhere, at your own pace, and even in your in your blankets. So thank you so much for watching this video. Okay. I'll see you in the next video.